So you can pause when we are discussing. Okay. So, hi. Arigatou gozaimasu, Oji-san. So today's class we discuss a different topic. Okay. So we have completed pattern mining, clustering, and now today we are moving to classification. So here is the thing. So when you look at the types of learning, okay, we have already covered this topic. We have unsupervised learning and then supervised learning. So in unsupervised learning, we have frequent pattern mining and clustering. Okay. So in supervised learning, we have classification and prediction. So without understanding classification, it is difficult to know what is supervised learning. So we start with the classification. Before that, just have a brief review. So what happens in supervised learning? I simply give you the data. Okay. What you have to do is you have to discover the knowledge. The knowledge can be patterns or the knowledge can be clusters. Very simple. Okay. So I just give you the data, raw data, not raw data, processed, but I don't know anything about this data. You simply cluster or extract patterns. But when we talk about supervised learning, okay, along with the data, I provide additional information. You can call them as labels. Okay. So for each data, okay, that is for each tuple, okay, I provide some additional data that you can call it as class label or simply labels. Now what you have to do is you have to discover the correlation between the data and the labels, okay, using a classification algorithm. So that can be a decision tree or any other one. Once you have understood the relationship between the data and the class labels, okay, next what I will do is I will give you some random data and you have to predict the class label. So that is what we are going to look at in today's class. So first I will be discussing with you what is a data and what is a label. After that, we will see how we will be building the models. And finally, we will look at how we use the length model to discover the class label. So before that, you should understand this time series, right? So when you talk about time series, you simply assume that it is a sequence of values. Okay. So this is the time series data. Okay. So this is how we are seeing, but this is not a line. These are some points. So this one is around like 58. This is like 1110. This is 65, something like this. Okay. So this kind of data is called time series. So I want to give you a small assignment. Okay. So people who are in the class, choose any value between 0 to 100. Okay. So we start from here and then you tell me any value. Yeah. 20. Next. 64. No, matte ko sign hai. Huh? 25. Hi. 32. 56. 50. 81, 30, 23. Huh? 33. Okay. Huh? 25. Next. 55. Hmm? 10. Hmm? 7. 99. Okay. So this is the data you are given. Okay. Now for this, draw the time series. Okay. So x-axis is time. Y-axis is values. Okay. So please draw the time series graph for these values. Hang San, please pause the video. Actually, please pause the recording. So, yes. Hi, okay. So, roughly it starts, okay. So, 20, 64, 25, 32, 56, 50, 81, 13, 33, 25, 55, 20, 27, 10, 7, 99. So this is how the figure should lie. Okay. So next time, whenever you are seeing this figure, okay, always think this graph is coming from a continuous sequence. Continuous sequence. So what we mean a continuous sequence? Continuous sequence means we are taking up data at uniform intervals. Continuous sequence implies data collected at uniform time intervals. For example, I will say at timestamp 1, okay, 20. At timestamp 2, it is 64. At timestamp 3, it is 25. At timestamp 4, it is 32. And so on. So, because this is going to be uniform, okay, we can skip it. Okay, we can simply say this as 20, 64, 25, 32 as a sequence, okay? But every sequence has time, T1, T2, T3. So this is your timestamp. Okay, is it clear? So next time when you see the graph, always keep in mind that there is a continuous sequence of values. For example, if you look at stock market data, daily temperature data, your marks, okay? So they all have a sequence. And this sequence represents time series. Now, this is how it looks. Okay. See what so this is just the ID. Okay. So I will give you the ID and then I am giving you time series data. In addition to time series data, I am providing you the class labels. Okay, so assume that there are COVID patients. Okay, so for COVID patients, we are collecting some data. Okay, so assume this is this time. Okay, so at every 1 hour we are collecting in the hospital, we are collecting the data for the COVID patients. Let us assume this is blood pressure. Okay, so when I say the class label as 3, what it means is doctor. Okay, COVID patients with no problems. Okay, so they did not go to, okay, what do we call the, so they just stayed in the hospital for 15 days, they recovered and they went back. Okay, so they did not face any problem. If the class is 2, it means COVID patients who faced problems and went into intensive care unit. Okay, so intensive care unit is when we put high oxygen and everything. So let us assume intensive care unit. I see. Okay, and the class 1 means COVID patients who died. Okay, so we have 3, the COVID patients who died. So we are having 3 classes. So I am collecting the data for the patients, and when they are going out or anything bad is happening, I am putting the label. Now I am giving you this data of one more patient. Okay, so a new patient came, we have collected this data. Okay, now you have to predict, okay, whether he will face any problem, he will die or he will be healthy. Guess kudasai. Okay, understood what is a label means? So label is something that human will provide. Okay, wakarimashita? What is the meaning of label? Is there anyone who don't understand the meaning of label? Okay, wakaranai. Okay, so this is the time series. Okay, okay, so I will say label is something that user will provide. So here I am saying, okay, if this kind of time series exists, then he is very fine. Okay, so let us take one more example. Okay, so let us take 2 cases. Okay, so COVID patient, not COVID patient. Okay, 2 classes. So how many of you know glucose? Oxygen level, wakarimasu? Blood oxygen levels. Okay. Okay. So they generally vary from 99 to maybe less, around 10 to 0. Okay. So assume I have a patient 1. Okay. So we are collecting his glucose levels for 12 hours, or let us say for a day, 24 hours, 2-hour interval. Okay. So this is 0, 0. So at 0 hours, he has 99. At 2 hours, he has 99, 98, 96, 99, 99, 98, 97, 96, 99, 98. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is every 2 hours he has given the data. Now there is one more patient. So he is patient 2. I am taking patient 3. Someone tell me some random values. 93. Next. Okay. Fast. 90. Okay. 96. Next. Okay, you keep on telling the values. 95. Okay, next. 90. Okay. No, we can't put 61 now. It's too late. It will mess up the things. Put everything around 90. 91. 93. Okay, 94. Okay, assume we got this data. Okay, so we are collected this data. Okay, now the doctor will come. Okay, so these 4 people have given this data and they went back to their home. Okay, after a few days, person 2 came and said he has COVID. Okay, and person 4 came and he has said COVID. Clear? So he did not come. So, and he did not come to the doctor back. So there are no COVID patients. Okay, so this is the label. Okay, Vimashta. So instead of saying no COVID, I will say 1, 1. For COVID, I can put 2. Clear? So this is label. Now assume a new person came. Okay. So his recordings are like this. Okay. Now doctor has to predict whether he will get a COVID or not. Okay, Vimashta? Okay. And if there is one more patient, predict, okay, whether he is going to be a COVID patient or not. If he is going to be a COVID patient, we should ask him to stay indoors. Okay. If he is not a COVID patient, we can ask him to go to his home and stay with his family members. So if you want to give such thing, okay, this additional information is class level, and we have to do the prediction. So now is it clear? Data, class label. Is there anyone who don't understand? People who are attending the class online, do you understand what is the difference between data and the class label? Wakari naino hitoga aru imawa. Wakari mashitaka? Okay. Yeah. So the same thing. So here we have data and we have the class label. Our objective is you have to predict the class label. Okay. So the basic way we do it is called one nearest neighbor. That is nearest neighbor. What is the trick we do is we take the time series, okay, and you measure the distance, okay, for each of them. So what is the distance from this one to this one? For what is the distance between? Distance, I mean any distance, Euclidean distance, cosine distance, okay? So you have to check how similar this time series is with this series. Okay, Mashta? And then the one that is closest, ichiban no closest no class label, we will assign. Okay, Mashta? So first we have to measure the distance between the time series. Okay, and then we will assign the closest value. Now the question for you is measure the distance. You take only 3, okay? We'll do for, okay? Measure the distance between the 3, okay? And tell me the distance values for this function. So this is, and this one. So you measure Euclidean between training and test. So measure the distance between 1 and 2 and tell me the value. BNM? You know? But you can't see the class label. Plus 10 9 minus 10 plus 8 whole square, 8 minus, this is 10.2. Next one is 8.8. 8.18 whole square plus 8 minus 8.3 whole square plus 7 minus 7.1 whole square plus 6 minus 6. Next one is, this is 6.9, sorry, whole square. 6 minus 6.3 whole square, and so please calculate it and let me know. Hongsan, pass the recording. 1.7. Okay. Next for this one. Okay. Zero 8. Okay. So you can see that the test case is very close to the first case. Okay. So what is the class label now? 3. Okay. So this is called one nearest neighbor. Wakarimashita? Wakaranai no hito ga aru? Oji-san, wakarimashita ka? Hontoni? Okay. So now we will make the things complicated. So this is how we are trying to do, okay? So for each point, okay, we are measuring the distance. Okay? That is the Euclidean distance formula. And the one that is closest, we are taking the value. So this is what actually happening when you are calculating the distance. So you are taking the distance and you are doing the square. Then square, square, square. And over this, you are doing a big square root. And this is the value you are using to find the nearest neighbor. Okay, so you are doing it in math. The pictographically, the image will look like this. Okay. So let us generalize it. Okay. Sometimes what happens is the one that is closest may not always be yours class label. So what we do is we take the concept of KNN. So in the KNN, I choose K nearest neighbors. Okay, and among them, I will see the majority of the class label. And then I will choose that as the closest. For example, assume this one has 0.06 distance. Okay, this one is 1.76 hypothetically. Okay, and this one is 17.6 something. Okay, hypothetical values. So what 1NN will do is it will say this will belongs to class 2. Okay, because that is the closest. But it may not be because there are multiple cases. So assume this one is 108. This is 2.6. This is 18. This is 0.6. 0.4. Okay. Understood? Now let us take K is 5. Now tell me the closest 5 classes. Which ones? Tell me the ID numbers first. 1, 2, 3, 4, 7. These are the time series that are close to the test case. Desho? Wakarimashita? Wakanai hito ga aru? Wakanai agete kudasai, daijoubu. I will explain again. Because next one you are going to do dakara. Desho? Hi. So let me delete this. Okay. So correct distance measures. Okay. So closest ID of Oshito Kudasai. 7. Okay. Next closest one. Wait. Hi. 4. Next closest one. Next closest. Go Desho, we need 5. So Muikai, one more. 2. Okay, so these are the closest. Desho. So 7, so these are the time series identifiers. Now tell me class labels. Nana no class label wa? 2. Your no class label wa? San no class label? 3. Okay. Ichi wa? 3. 2 wa? 3. Okay. So even though Nana is the closest, okay, but many of them, okay, majority of them are belongs to class 3, Disha, majority. So in KNN, we put not 2 but 3 because majority this. Wakajimashita? Wakaranai no hito ga aru imamo? Daijobu? Okay. Good. So now exercises. Okay, so the most important point is this one. Yeah. So now K is 5. Okay. I am giving you a new test case. So this is 70. Tell me some values. Which should be closest. Yudo-san, tell me one value. 9. Okay, next. Mm. 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 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hi. Okay. Now check the distances. So from each class take 3, 3. It will take a lot of time, no problem. Most important thing is you guys should learn it. And tell me the distances. So let me know what top K equal to 5. So calculate and let me know the class label. So this is the class assignment. Hansam, please pass the video. Yes, what is the distance? Yoshite Kudasai? 9.35. Next. 9.80. Next. 10.30. Okay. Second, please tell me the distance. 8.52. 8.82. No, they should be 10. No, they all have 10. Okay, anyway. So how much it should be also roughly around the same. Okay? No, this thing, this side will tell. Kunda is Vasuri Chatta. Hi. Kazuki, hi. Tell me the value. Value Soshite Kudasai. Distance wa? 10? 11 Bishop? 9.6. Okay. Yude-san, no copy. Dekimashita, dekinakatta. Nemurimashita. Okay, nemurimashita. Okay. Nakamura-san, hi. 6 point. Okay, next. 7.25. Next one, I think Nakamas did it. Okay, what should take the side? 6.5. Okay. Now tell me top 5 ID numbers. Top 5. Chisaklo 6.5. Desha. This is the lowest. So 14. Next one. Please tell me the second one. Hi. Closest value wa? Kore was smallest desha. So dakara kokode juyon. Okay? Akaji masta. Next closest one. Next chisanawa. Daijoubu. Next chisanawa. No, kokode misete kudasai. Tell me from here. Near? Huh? 12. Okay. Next one. Next closest one. Thirteen 11 desho. Nana 10. Ichi. Next one is 30. What is the next one closest? Seven or 6. Which one is this chisana? Kochide. Chisana? Roku desho. Korewa hachi 10 yon ni. Korewa hachi 10 hachi ju ni. Korewa lowest desho. Dakara roku. 6. Akadimashita? Akadaina hito ga aru? Minasan? No. Now tell me the class labels. So, Ichi, okay. 12 no class label va? Okay. 11 va? Okay. 30? So majority va? Ichi? So the class label for Uday-san is Ichi. Okay? Understood? Clear? Okay. Now, I have a question. Do you like this method? Daijoubu? Okay. Do you find any problem? If you find any problem, oshite kudasai. No, don't worry about wrong or right. Be brave. You know the proverb, right? Yeah. Close by. Yeah, close to answer. Yes, but not perfect. Okay, give it a try. Close. You are close. Almost close. Or do you see a problem? Outliers? No problem. Right now, don't worry about outliers. We will discuss about it later. That is also one of the problem. Accepted. But what is the major problem in this approach? The first answer is very close, very, very close. You just have to go beyond. Just you have to put one more step. Then you will get the answer. But very, very close. Do you guys see any problem? Oji-san, taihen mieru? Yeah. Problem ga mieru ka? Every algorithm has a weakness. Okay? So, kono algorithm mo weakness ga aru. Ippana weaknesses ga aru. Can you see them? Correct. Do you know the name of the problem? Class imbalance. So what Nakamura-san is saying is, if I have many, okay, of class 3, I will have many. And for class 2, I will put only 2. And class 1, if I have only one case, then the algorithm, yes, that is class imbalance problem. Yes. Okay, yes. That is one major problem. That is for every algorithm. But these algorithms have one specific problem. Data shorter means? Sometimes it means, yes. That is called imputation. We try to fill in the missing values. But assume this same data is, there is no missing data. Then what is the problem? Both of you are close by. Why do you think you are calculating unnecessary values? Yeah. Yeah. So you guys are looking at, so you have many combinations. Some of them may be far away. Try to calculate. Close by. But there is one major. Close by. You both are very close. Each point is valid. Class imbalance is one of the major problems. But I don't cover class imbalance in this, okay? If you want, you have to look at the techniques called bagging, boosting, ensemble classifiers. They are different. If you want, we can take one Saturday or Sunday and we can cover those topics. But what is the problem? There is one major problem. The problem is, okay, in the real world, okay, this training data set can be in millions or billions. Okay, you have many data. Okay, so if you have, let us take a million, and for each test case, if you want to do very combinatorial expression, but this is called large training data set. Okay, so if you have a very, very large training data set, these approaches are computationally expensive. Okay, you have to do the clustering, and then what to do, try to do is you take the each class, try to get the cluster, okay, that is the centroid, and you take the points that are close to the centroid. Okay, Rimashta? For example, okay, I am giving one class. Let us say I have many classes. So these are the class label, class ID 111, and there are several values. Okay, you take this is as this is 10 lakhs, each million for the class level. How do you do? One thing is, I don't take everything. Instead, I will do clustering. Okay, so I find one cluster, I will find one more cluster, I will find one more. Let us assume k means where k equal to 4. Okay, and you can increase the k value depending upon how many cases you want, and then you say this is the centroid for all of them. So 1 C1 centroid, class 1 C2 centroid, class 1 C3 centroid, class 1 peaceful. ఒక్కరిమస్తా ఒక్కరన్నాయి ఒక్కనైనా హితగారు. So first one is, if you have many for the class, you try to do a clustering, and then you take the centers. Okay, so what happens now, instead of these values, you keep the center one. Okay, so cluster center, centroids of each cluster, and you do it. So that way people try to avoid too many cases, but still this is large. So that is why deep learning algorithms, okay, they take a lot of time to train, because they have to reduce these many times in training data into fewer cases. Okay, so they take a lot of time, but I am not covering it because this is not the deep learning course. But you understand, if the training data set is very large, the nearest neighbor algorithms don't work. So we look at clustering and other approaches to solve the problem. But other than that, there is class imbalance problem also that will be solved by any other algorithm. But my PhD student is there, Rajisan, okay? So he came up with one important part. What he came up with is very interesting. In the existing algorithms, okay, in KNN or nearest neighbor, we measure distances between the test case. I think this is training case, sorry. Yeah, this is training case and the test case. Okay, so you take the training set and then you take the test case. You measure from point to point. Okay, what he said is that may not be wrong, because at each timestamp, okay, a class can take a range of values. Understood? If you see here, okay, you see at timestamp 1, the class 3 is taking 10, 10.3, 10, 10, 9.7, okay? So it is taking a range of values, 9.7, 10, 10, 10.3, 10.9. Disha? At timestamp 1. So it is taking so many values, okay, the blue ones. Similarly, at timestamp 2, it is taking a range of values. Timestamp 3, it can take a range of values for each class. Okay, Mashta? 9. How many of you could not catch up? Occur 9. Okay, so let's go back. Delete one muri nande. Now they are going. Kare wakarimasu ka? Kono values wa? 9.7 wa timestamp ichide aru desho. Okay. Next to Ju. Ju 10 3 desho. 10. Kore values ga arimasu desho. Okay. So if I kono timestamps there, kore wa ichi desho. So 9.1 wa Kochi. 10 wa Kochi. 10 make 10 more Kochi. Okay. 10.3 wa 10.9 wa Kochi. Kore jambu range of values. Akarimashita? Now tell me for 2 times that. Oshite kudasai. What are the timestamps? What are the values? First tell me the values. 9, 9.8, 9.4, 10, 9.2. Okay? Okay? So for this one, it is 9. So let us put it here. Then 9.8, 9.4, 10, 9.1. Daijoubu? Wakarimashita? Wakaranai no hito ga aru? Okay. So if you understood, then draw the figure for 3 and show it to me. Okay. Rajasthan, please show me. I can't see me and I'm hi, okay, there. Hi, thank you. So, for 3, what is the values? Oshite kudasai. Hachi. Hachi to ni. Ni 8.2. Okay. Next. 8.2. 8. So it will be roughly around here, no? 8.8, 8.8, 8.2, 8.5. So something like this, it will come. Okay. So these many values can, the timestamp can vary. Okay. So in that case, choosing only one, he is wrong, he says. Okay. So these are the values. So if they are varying the values like this, okay, and the test case can take any value. Okay, master. So his idea is very simple. These are the values, right? So you make a 12. Yeah, my wife calls. So we make something like a box plot, or you can simply say maximum, minimum, average. Clear? For each one, you take max, min, average. You do for every timestamp. Okay? What it means is, at each timestamp, for a particular class, value can vary between these max minimum values. Okay? Clear? Hontani? Okay, man, anyway, we'll do it next class also, don't worry. So we do the same thing. Okay? So what we do is, we take the minimum, we take the mean, that is average, and we take the max. Okay? So I don't care how many are there. For each class, I will take minimum, maximum, and mean. And I will measure the distances between them, but not using Euclidean, but we use something called fuzzy distance. So what the fuzzy distance? Okay, so let us assume this is the one. So at a particular timestamp Ts, I know maximum, I know minimum, and I know average. Desha? Which one we take? Let us take. Now, the test case, okay, at the timestamp can be sometimes here above maximum. I can get the case that is above maximum. I can get the case below minimum, or cases in between minimum, maximum, like this. Akarimashita? For example, okay, this is the case ratio 9.7, 10, 10, 10.3, okay. The first timestamp, what happens if it is 11? Outside this, what happens? It is 8. Outside the minimum. Okay, so outside maximum I can see a value, outside minimum I can't see the value, and between also I can see. Okay, understood this philosophy? Okay, so in my training set I know the minimum, average, maximum, but the test case, its value can lie below minimum, more than maximum, or in between. Okay, so now we came up with this formula. If the test case is below minimum, okay, I don't know anything about it. Desha, because I have not seen it in my data. Watashi no data de below minimum wa watashi wa miranai. I don't know. Okay, kore hajimete desho minimum wa. So I don't know. So fuzzy ne ichi value. Desho maximum wa 0 kare ichi dake desho fuzzy ne. So minimum, okay, so vector kare demo, if it is minimum, less than minimum, I give the fuzzy value of 1. Okay, okay. Similarly, max value, if I observe, then the value is going to be 1. Okay, huh? 0 means closest. 1 means farthest. In the distance measures, 0 means we are close by. The distance between us is 0. If distance between us is 1, then you are the longest for me. Okay? So everything generally ranges between 0 to 1. 0 is closest, 1 is the farthest. Sometimes it will be opposite. 1 can be closest, 0 can be. But generally, in fuzzy case, we assume 0 is the closest. Okay? So, if the value is below minimum, fuzzy distance is 1. If the value is above maximum, fuzzy distance is 1. Okay? Now, if the value is close to minimum, okay, then I am going to give 0.5. Okay? And if it is close to center, average, it will be 0. Okay? Similarly, if it is maximum, again I increase to 0.5. So as from the minimum, as I move closer to the average, the distance decreases. Okay? And from minimum, from the average, if I move towards maximum, the distance again increases. Okay, Masta? Okay, I know hitega ippai garune. Okay, Masta? Okay, let us do the same. So, chicken one eye. So everyone was good for 3 bishop. Okay, 3 were dekimashita. Okay, now tell me minimum. Minimum what? Maximum what? Average what? Calculate kuda sir. Eight point 18. Okay, so Korora Hachito, Hachiten Goto, average wa kuch. Okay, now I am giving a test value. Nana dokore test value wa nana. Dokore iska kono point wa. Now everyone put the point for nana. Make it the bigger one. Okay, Okino circle wa. Please draw Okino circle. Okay, big circle for nana. Have you done for nana? Yes, Okino circle. Make it big. So I can see it. Dekimashita? Nana no circle wa doko. Kochi ima watashi no value wa kochi desho. Kokore nana no circle wa draw kudasai. Okino. Circle. Maru. Gomenasai. Maru. Okino maru. Draw the Okino maru. Nana. Dekimashita? Draw kudasai. San no nana. Okay. If nana finish, then draw for Ju 10, yeah, Ju ichi. Nana ga owari mashita toki ni Ju 10 ichi draw kudasai. Dekimashita? Then put one more circle for Hachiten ichi. Next, draw the Maru, Okino Maru for Hachiten Yon. Dekimashita? Completed? Everyone? Is there anyone who did not complete? It's time, but I'm not going to say. Let us come at least understand the basics. Dekimashita? Wakarana katta. Okay. So, how do you write the points? So, Hachiwa minimum desho. So, Hachi. Hachi 10 Hachi. Average one unknown value. Yeah. Maximum go Hachi 10 go. Desho? Test no case one. Ichiwa nana. Okay. Next one wa Juichi. Max to minimum to average. Desho? What is the next one? 8.1. So the kuchi. Next is 8.4. Remember test cases, Desho. Okay. So, what is the fuzzy value for Nana? Nande. Okay. Watashi wa kochi kara kochi dake wakarimasu. Watashi no training data de values no kochi kara kochi dake dakara kore wa wakaranai. So, distance wa 1. わかりました？同じ。私は 8.5 だけわかります。11はわからない。だから、このファジーディスタンスも1。わかりました？ 8.1 はわかる。これはミニマムとアバレージの中であるだから。So, this is the fuzzy distance. Similarly, this one also. Wakarimashita? So, what is the fuzzy logic? The distances are minimum to ka maximum no minor value ga aru tokini ichi. Otherwise, 0.5 kara. If it is close to average, then I am similar. Otherwise, it is going to be 1. Wakarimashita? So, this is the fuzzy function. Okay? Koreva test case. Test case no value minimum no shita ga aru tokini ichi. Maximum no uye ga aru tokini ichi. Mean ga aru tokini 0. Okay? In between kochi kara kochi to kochi formula. Kochi kara kochi to kono formula. Okay? This is fuzzy equation. Now how to move to the next step. So now what you do is you draw the lines. Okay? So minimum to mean to maximum no line ga draw kudasai. Okay? Now you put the dot. Kochito. Okay? You draw a line. Now for this value, check to the side. Okay? Now you can see this. So koreva max, koreva average, minimum. Shita desho? Minimum. So watashi wa wakaranai. Dakara fuzzy value wa 1. Next, how to undo? Similarly, maximum minus aru dakara wakaranai. Fuzzy value wa 1. ಸಣ್ಣ ವ್ಯಾಲ್ಯೂವ ಮೀನ್ ನೋ ಚಿಕ್ಕ ಹಾಕುದೇ ಅದು ಆವರೇಜ್ ನೋ ಚಿಕ್ಕ ಹಾಕುದೇ ಅದರ ವ್ಯಾಲ್ಯೂವ 0 onaji. Okay, so now you get these values. Okay, kono jumbo fuzzy values na average kudasai, and that will tell you the distance function. Okay, so use that distance function to see which class it belongs to. Okay, so this is what, and this is called fuzzy time series classifier. This is the best algorithm known to the humankind until today, published in IEEE Fuzzy 2021, this year's work. So if you want to this nuisance again, so if you can find any problem in this fuzzy classifier, you can make one more best algorithm. Okay, so we will continue this one in the next class. Okay, so but obey to the side. Okay, don't forget. Okay, so we will do this one by hand in the next class. Okay, yeah, we can leave now. So Hanson, please stop the recording. Thank you.